Hello everyone, welcome back. So today we'll learn how to do polynomial long division. Our goal is to be able to do that, divide polynomials that way. And then also be able to use and understand what I call the remainder and factor theorems. We'll explain those as we go. So let's talk about polynomial long division. So you're probably familiar with numerical or number long division, though you may not have done it by a long time. It's dividing by hand numbers. So we use calculators these days, and most of us don't use much anymore. But we're going to show that it's very similar to that. So in kind of a mathematical way, we'd say that if p of x and d of x are polynomials, so we start out with p of x divided by d of x. Of course, d of x can't be 0, or else it's be undefined. Then what's left then, the answer is the quotient, q of x, and then a remainder, these can all be functions of x, r of x over d of x. Now, basically, this says the same thing here. And once again, I know there's a lot of mathematical terms. Let's explain what this means kind of in a real way. So we take a number, what's called the dividend, we divide it by what we're dividing by called the divisor. What we're left with, the answer is a quotient. If there's a remainder, we write that as remainder plus the remainder over the divisor. And we'll see that in examples. And also what that means is that the dividend, which we're dividing into, is equal to the divisor, what we're dividing by, times the quotient or answer, then plus remainder if there is a remainder. We'll see some examples of that, and we'll talk about these couple of factors. A few more things. If I have a polynomial, first called the remainder theorem. I have a polynomial p of x. You divide it by x minus c. The remainder is this value p of x, or p of c. Okay? Or here, the switches signs. If it's minus here, it's positive here. And if it's positive here, it's minus here. But what this means then, if we want to find the remainder, then we plug c in, and that will give us our remainder. Then also, if x minus c is a factor of our polynomial, of course, our remainder will be 0. And it brings us then to the factor theorem. So the number 3 is a 0 of p, the polynomial, if and only if x minus c is a factor of p of x. And once again, if number c is a 0, that means p of c is equal to 0. And we'll work with those theorems as well. Okay. And then finally, let's talk about kind of how we're going to divide our general method. So divide a polynomial, you write the dividend in descending order, if necessary. If the dividend or divisor dividend, what we're dividing into and what we're dividing by, are missing a power of the variable, we'll insert this power with a coefficient of 0. That just kind of as a placeholder. We'll see an example like that. Then we divide with the method we're about to show, then write the answer in the form above. So when we write the answer then like this, the quotient plus remainder over the divisor. So after saying all that, let's first look at an example with just numbers. So hopefully we'll help you recall how we divide. Here I'll just say divide. And once you do an example with numbers, that will help us then see how to do an example with polynomials. Okay, so let's do this. So I want to divide 5,423 by 15. All right, so we're going to do this the long way. You've probably seen before. So I hope this will bring back some memories. I hope there's some good memories. But it's the dividing line, then 15 into 5,423. Okay, now this is your dividend. That's what we're dividing into. This is the divisor, that's what we're dividing by. Then we're going to divide it and get the quotient, then a remainder if there's a remainder. Okay, remember how this worked is we looked at 15. So we look over here and say, well, of course, 15 won't go into 5. So move over and says, well, will 15 go into 54? And it will. How many times will it go into 54 evenly? Well, it turns out it'll actually go into 54 3 times. So write that here. Then multiply 3 times 15, which is 45. Okay. And what was next is we subtracted, and that's the effect of changing our signs. I like to circle it. So this was a positive, now it becomes a negative. We change our signs, and then we combine these. 54 and negative 45 gives us a 9. Our next step is we bring down the next number, which is a 2. We start that process again. How many times will 15 go into 92 evenly? They go into 92 evenly 6 times. Write the 6 beside it, then multiply. 6 times 15 is actually 90. Okay, once again, we're going to subtract. So we change our sign here, make that a negative. So positive 92 and negative 90 is 2. Once again, bring down the next number and repeat the process. How many times is 15 going to 23? Just once. Okay. And 1 times 15 is 15. Then, once again, change your sign. We subtract positive 23 and negative 15 gives us a positive 8. And now we're done. Okay. There's nothing else to bring down, and 15 won't go into 8 evenly. It's not big enough. That's how we know we're done. All right. Once again, a few things. So this, let's recall this here is called the divisor. This number is what's called the dividend. No, dividend, the D, not with the T. This is the quotient. And of course, this is the remainder. Now, I want to write our answer this way. I'll just say, so what we have then is that 5,423 divided by 15 is equal to the quotient. So let's take a look over here. All right. The quotient plus remainder over the divisor. So the quotient, which was 361, plus the remainder, 8, over the divisor, which is 15. Okay. Now, is that true? Well, let's actually check. Let's actually take a look at Desmos. And if you remember, if you know, you can actually do just calculations on Desmos, not only graphing. Let's do that. So 5,423 divided by 15, 361.533. Okay. Now, if I just do the 8 divided by 15, remember that was our remainder over our divisor. Yeah. So we said the answer was our quotient, which is 361, plus remainder over the divisor, which is 8 over 15, and that's where the 0.533 repeating comes from. So that is correct. Okay. So that's how we remember then divided by hand. So now let's take a look at some examples where we divide by polynomials. Actually, just one more thing here. We can also write this: dividend is equal to divisor times the quotient plus the remainder. Let's check that. So, then I'll just say also 5,423 is equal to the divisor, which is 15, times the quotient, which is 361, plus 8. Okay. Now, is that true? Well, check that on your own. Multiply that. So 15 times 361 is 5,415 plus 8. And if you add that, you get 5,423. Okay. So that's an example of numbers. As we'll see, an example with polynomials works very similarly. So let's take a look at our first one of those. So let's say I want to divide this. B squared minus 14b plus 49. I want to divide that by b minus 7. Okay, so I set up the same way. Let's actually go down here, look at our process. So write the dividend in descending order. The dividend is this, and actually want both descending order. Remember, descending order is highest power of the variable, the next highest power, then down to the constant, if there is one. So we're going to write the same way. So we're going to have our b minus 7 and divide that into b squared minus 14b plus 49. Okay, write out the same way. Okay, now we're going to divide very similarly. So what we want to do then is we want to match this term. This is the b squared. We have a b. Okay, what do we need to multiply b by to get b squared? That's just going to be b. Okay, now, like we did before, multiply now. So b times b. Also write the b's over its, this is a placeholder over its, the same power of the variable. B times b is b squared. Then b times negative 7 is negative 7b. Okay, now we subtract. That means we change our signs. So this now becomes a negative. This becomes a positive. I just like to circle my new signs. Subtracting changes our signs, switches our signs. Now I combine these. Now this should always cancel out here. Then what we have left is negative 14b plus 7b gives us negative 7b. Okay. Then, like the example above, we bring down our next term. plus 49. And we repeat that process. I want to match this term, so what do we need to multiply b by to get negative 7b? That's going to be minus 7. Once I choose that, multiply. So negative 7 times b is negative 7b. Negative 7 times negative 7 is plus 49. Okay. Once again, I'm going to subtract this. It means I change my signs. This becomes positive. This becomes negative. I combine those. Of course, that's 0. This is also 0. Okay. Now, am I done? Well, yes, I am. 2 reasons. Here, there's no b left. There's nothing I can multiply in terms of polynomials b by to get a 0. And also, there's nothing else to bring down. That means I'm done. Okay. So what this tells me then is that b squared minus 14b plus 49 over b minus 7 is equal to just b minus 7, our quotient. All right, is quotient plus remainder over the divisor, but since there's no remainder, it's just b minus 7. Okay. And also, what this means is that I can write my dividend b squared minus 14b plus 49 is equal to the divisor b minus 7 times the quotient b minus 7, or it becomes b minus 7 squared. Okay. Now, let's also look at a couple other implications of that. So let's go back to these theorems we mentioned. Okay. The remainder theorem. Okay, says the polynomial is divided by x minus c. The remainder is the value p of c. Okay. Now, if I call this, let's call this polynomial p of b. Okay. Let's basically plug in. What we're going to do is plug in 7. Okay, so we divided by x, b, or b minus 7 in this case. Let's plug in 7. We're going to switch our signs. This is negative. This becomes positive. This is negative here. This becomes positive. So p of 7 is equal to 7 squared minus 14 times 7 plus 49. If you check that, you'll find that's 0. So there's no remainder, and there isn't. Okay. So from our remainder theorem, we know from our division we just did that there should be no remainder. And if you can check this, this can be 49, another 49. This can be negative 2 times 49. This will actually give you 0. Okay. And then the factor theorem. Factor theorem says that the number c is a 0 if and only if x minus c is a factor of p of x. Okay. So what we know is that b minus 7 is a factor. So b equals 7 is a 0. Okay. And we saw that, okay, by plugging in 7, we got a 0. That's what it means for you 0. You plug in a number, the result is 0. Also, if we graph this, we'd see the graph crosses the x-axis at b or x equals 7. Okay. Actually, just a minute. Let me check and make sure I have enough space for the next few we need to do. I'll do more than enough here. Okay, good. Which means more than enough. Okay, let's take a look at our next example. Number 3. Let's try and decide which one I want to do next. Okay, let's do this one. So 2x squared minus 9x plus 8 divided by 2y plus 3, or 2x plus 3. Okay, let's divide this. So once again, I write it out in the division form. Also make sure everything is ascending order, also no missing powers. We'll see one of those in a moment. And so this is going to be 2x squared minus 9x plus 8. Okay, now start again. So I want to match this term. So what do I need to multiply 2x by to get 2x squared? That's just going to be x. Okay, I do that. X times 2x is 2x squared. Then x times plus 3 is plus 3x. Okay. Now, once again, I subtract, which changes my signs. This because sign becomes negative. This also becomes negative. These should always cancel out, and they do. And over here, I have negative 9x and negative 3x. That's negative 12x. Okay. Then bring down my next term, which is plus 8. Okay. And repeat the process. So I want to get negative 12x. What do I need to multiply 2x by to get negative 12x? That's going to be negative 6. Okay. Then multiply. Negative 6 times 2x is negative 12x. Negative 6 times 3, positive 3, is negative 18. Once again, I subtract, which changes my signs. This becomes a positive. This also becomes a positive. And now these cancel out as they always should. And over here, I have 8 plus 18, which is 24. Okay. Now, once again, I'm done because there's nothing else to bring down. And also, I can't get 24 from 2x. So I'm done. Okay. So our result is 2x squared minus 9x plus 8 over 2x plus 3 is equal to the quotient x minus 6 plus the remainder, which is now a remainder of 24, over the divisor 2x plus 3. Now that is how we write our result. Okay, so this is the same thing as that. And if you ever take a calculus class, especially in calculus 2, which you may learn in dividing something or doing what's called an integral of something like this, it's much easier to do this than it is that, the way it's written. Okay. Also, one more thing from the remainder theorem. Okay. Then, if we plug this in, so we divided this by 2x minus c. Now, this is actually going to make it a little bit harder to. Actually, we'll skip that for now because it's still true, but it's a little harder to. When we have, it's a little harder to explain it. So we'll actually save that idea for the next one. But still, the same thing works. In this case, you're not plugging in 24. You're actually plugging in something else, slightly different. Okay. So let's take a look at our next one. Okay, let's see. Check and see which one I want to do next. Actually, that's okay. Look at our next one. So this should be number, this was number 4. Right, number 4. This time we want to divide x squared plus 4 by x plus 2. Okay. Now, you notice this one is actually missing a term. So what I mean by missing power of x, it goes from x squared straight to the constant. There's no 0. There's no x term. So we're going to take care of that is from our discussion. So it says that the divisor and dividend is missing a power of the variable. Insert the power with a coefficient of 0. Explain what that means. We're going to divide this first. This is our divisor, x plus 2, into this. So we're going to write this as, of course, x squared, then plus 0x plus 4. Okay. Now, that's exactly the same thing. Notice 0 times x is 0. So we haven't changed this. We haven't changed what it means. We just inserted this as kind of a placeholder to make the process work. Okay. But it works exactly the same way as we've just been doing. So I want to match this. So what do I multiply x by to get x squared? That's just going to be x. So x times x is x squared. X times positive 2 is plus 2x. And then you've seen this process before. We subtract, changes our signs. This is negative, is also now negative. These cancel out as they should. 0x and negative 2x leaves me with negative 2x. Then bring down the plus 4. And start again, okay? Want to match this. What I multiply x by to get negative 2x will be negative 2. Then multiply. Negative 2 times x is negative 2x. Negative 2 times positive 2 is, of course, negative 4. Okay, once again, I subtract. It changes my signs. This becomes plus. This also becomes plus. These cancel. And now these, plus 4 and plus 4 is 8. And once again, I'm done with the division because there's nothing else to bring down. Also, there's nothing I can multiply x by to get just 8, okay? So our result is that x squared plus 4 divided by x plus 2 is equal to the quotient x minus 2 plus the remainder 8 over the divisor, which is x plus 2. Okay. Now, a few more things. Let's go back here. I can also say I can say that this is true. So the dividend, which is x squared plus 4, I can also say is equal to the divisor, x plus 2, times the quotient, x minus 2, plus 8. Okay? It turns out that's also a true statement. Actually, we can check that really quickly. Let's do that. So if I FOIL this out, and actually this is difference of squares, this will be x squared minus 4, difference of squares plus 8. And that, of course, if I combine my like terms, is x squared plus 4. Okay? Now, let's take a look at the remainder theorem this time. This one is easier to understand. So let's go back to the remainder theorem. And what it said is that the polynomial is divided by x minus c. So in this case, I divided it by not x plus 2. So what that means is that p of c is a remainder. So call this p. Now this time, I know it's divided by x plus 2, and this has opposite signs. So this is a plus, so this is going to be a minus 2. Okay, I'm just going to plug that in to my original function, x squared plus 4. This will be negative 2 squared plus 4. And of course, that's going to be negative 2 squared is 4, then plus 4 is equal to 8, okay, as it should be. Now here, the factor theorem doesn't work for me because we don't know what a factor is. Since we had a remainder, then this was not, since we did have a remainder, then x plus 2 is not a factor. Okay, if it was, then there'd be no remainder. Okay, let's see what's next. Let's do one more, number 5. Okay, this time let's do a larger polynomial, and let's actually write it. So let's say we have 7x minus 6x squared plus x cubed minus 1, okay? And we're dividing that by x minus 1. Okay, now, once again, what I need to do here is, this is another one of the statements, is also want to make sure everything is written in descending order, so I want to write in descending order. Okay, so write in descending order. And so what I can do it here as I do my division. So I have x minus 1, that's my divisor, and then my dividend in descending order. Highest power is cubed, so positive x cubed. Next highest power is x squared, so minus 6x squared. Next highest power of x is plus 7x. Then finally, my constant is minus 1. Just make sure it's in descending order. Now, this is a longer one, but you see everything works exactly the same way. So now what I'm going to have to multiply x by to get x cubed, that's going to be x squared. So put that over the x squared. And x squared times x is x cubed. X squared times -1, of course, is -1, or just negative x squared. Everything works the same. Subtract, change my signs. This is now negative. This is now positive. These cancel out. Here I have -6x squared and plus x squared. That'll be -5x squared. And then bring down the next term, plus 7x. And now repeat. What do I need to multiply x by to get -5x squared? That will be -5x. Do that, multiply. -5x times x squared is -5x squared. And -5x times -1 is plus 5x. Once again, we subtract, which changes our signs. This becomes a positive. This becomes a negative. These cancel out. 7x minus 5x is going to be plus 2x. And once again, bring down the -1 and start the process again. What do we need to multiply x by to get 2x? That's just going to be plus 2. Plus 2 times x is 2x. Plus 2 times -1 is -2. Subtract, change our signs. This is negative. This is now positive. These cancel out. And so I have -1 plus 2. Our remainder is 1. Okay. So now I can write this either in descending order, the original order, doesn't matter. X cubed minus 6x squared plus 7x minus 1 divided by x minus 1, okay, is equal to the quotient, what's on top, x squared minus 5x plus 2, then plus the remainder, which is +1 over x minus 1. Okay. And also, if your remainder had been negative, then you just put that as just a negative. So it would be minus x minus 1 over x minus 1. Okay. And then you can check this on your own with the remainder theorem. If we plug in, so we found out that x, we divided by x minus 1, you got a remainder of 1. We plug +1 into this and find it, you'll find that it's, you plug in, +1, which is right here, since we switched the sign, plus 1. Into this, you'll get the remainder of 1. Okay, now let's ask a few more questions. So let's take a polynomial. In fact, let's do what we've already done. So let's say, let's see, for this one, I want to say what number I'm on. I guess this is number 6 or 5, so 6. Number 6, okay. So starting with this polynomial, we've already seen this one, just as used to be. So we had x squared minus 14x plus 49. We've already seen this one. Okay, let's call this p of x. That's our polynomial. Okay, I just used a b previously, but we use the same polynomial. Okay, now we saw that x equals 7 was a 0. I plug that in. So then x minus 7 is a factor. That's what the factor theorem tells us. Also, if you plug in, but now that's for x equals 7, and x minus 7 was a factor. Now, what if you did -7? Okay, is x equals -7? Well, here, let me ask the question this way: what if we had is x plus 7 a factor? Okay, well, how can we find out? Well, from the remainder theorem, I was going to abbreviate it. It's a remainder theorem. Okay, let's try p of positive. So this would lead to, hold on, so where we switch our signs. So x plus 7 would give us an x equals -7. Okay, so we're going to say and p of -7. Let's find out what that is. Once again, we can actually use Desmos to help us out. We do a quick calculation or on your calculator. So let's do -7 squared, okay, minus 14 times -7, okay, plus 49 And we see that's not 0, okay? It equals 196. Equals 196, okay? What does that mean? This is not 0. Also, what this number is, so if I went through the division process, I would get this as my remainder, okay? This is not 0. So from our factor theorem, okay, from this part, what that says is that since x equals -7 is not a 0, and here we make sure it's clear. So if this had been 0, then if this had resulted in 0, this would have been -7 would have been a 0 of the function. So it's not a 0 of the function. Of p of x. Then what we can say from our factor theorem is that x plus 7 is not a factor. Okay, so we can tell us there that that's not a factor. So if we go through the division process, we get remainders, so we get this remainder here. Okay, let's kind of review what we've learned. So what we've learned then is how to do polynomial long division. We saw that's very similar to, in process, the way the process to numerical division goes by hand. We also found out how we can write our answer in this form of quotient plus remainder over divisor. And once again, if there's no remainder, our quotient is actually a factor. And then we learned what the implications of the factor theorem and the remainder theorem are for these. Thank you. Have a good day.